Make a pain on it.
Okay, we can see.
Yep. All right. You can see, right? Thank you. So, good evening once again. Welcome to the day two of getting Oracle Database Fundamentals Right session or series. And today we are going to focus on a little bit on storage management. So that's Oracle's automatic storage management, or what we call ASM. So we'll try to understand some concepts around this. Now, this is actually a very huge topic, a big topic, and sometimes it might be a bit difficult for you to grasp at the in a short time. But we are trying to give you the best that we can. So if there is a requirement of going into multiple sessions of this, feel free to let us know so we can do a bit more exploration and we can do more deep dive onto this topic. But for now, let's try to focus on today's topic, which is ASM, right? So now, as we know, so let's before talking about ASM, we'll see why we need storage, right? So in a database, obviously, in order to store your content, you need to have your storage, right? So if you spin up a database, so be it anything, I mean, it could be Oracle database, it could be any other type of database, you still need to have your files stored. So you store your files on a storage. So when you have your storage, the storage has to be configured. Now, say, take an example. If you add a new disk to your laptop or a desktop or one of your computer systems, then immediately the disk is not really. I mean, you cannot use the disk for your own purposes, right? So you in your configuration, or maybe your in Windows, you have this some tools that you have where you can see that the disk is plugged in, right? You could see it as a raw device, which we call, just a disk, right? But then you cannot make use of it as is. So what you do is, once you have plugged that disk into your machine or to your server, right? Then what you have to do is you have to first do formatting, right? Just like how you plug in. Now, the moment you initially plug in a USB, even you have to format it, right? Then when you're formatting it, it asks for you to. I mean, along with formatting, it will ask you to figure out the file system that you need to incorporate, right? So if it is Windows, we have FAT32, NTFS, right? And similarly for Linux, you will have ext4 and so on. So based on the operating system, you might be needing to put what you call a file system in order to make the disk visible. So what you do is, first you might sometimes be partitioning your disk into multiple components or multiple partitions, and then those partitions will be formatted with the file system that you prefer. Okay, and then once the file system is created on top of a partition or on top of an entire disk, then what you do is you have to mount that, right? So in Linux, you have Unix environments, you have to mount your system to a particular folder, and then that will be visible to the operating system. So people, based on the permissions, will be able to access and store data on those disks or partitions, right? So similarly, in Windows also, you have to partition it, and you might be formatting it. So once you have formatted it, then you should be able to assign a drive letter for that, and then you'd be able to based on the permission, you'd be able to store and retrieve data from that storage. So that's basically a storage for you. So in the database arena also, I mean, in the database world, again, it's the same thing, right? You need to have your storage. So how you present your this storage to the Oracle database is what we are going to discuss today, right? So when you're presenting your data, obviously the conventional methods which I just mentioned, where you find a disk and then maybe you may partition it, or maybe without partitioning also you take the entire raw disk and then you format using a particular file system, and then mount that file system and present that to the database to store data files, which is the conventional setup. right? But Oracle actually came up with their own solution in order to manage the storage, and that solution is what we call automatic storage management, or in short, ASM, right? So this mechanism was introduced in Oracle 10G. Prior to 10G, then we didn't have this mechanism of managing by Oracle the storage. So there were some challenges before, right? I'll tell you one example. Now, uh, when you want to set up a cluster, right? So cluster means you have a single storage and you will be having multiple machines connected to that storage in order to retrieve and data in a parallel fashion or concurrent fashion, right? So you might be accessing data from the same storage. Maybe the same set of data is accessed by multiple machines at the same time. So that's how the cluster works. So in order to tolerate or in order to meet those expectations, your storage or your storage has to be or had to be geared in order to support this kind of parallel work. Concurrent access should be possible and should be made available through the file system. So Oracle had previously a cluster system, which was called, I think, parallel server or something. I think, if I'm not mistaken, in previous versions, right, old versions. So these parallel servers, and even in 9.9 version 9.9, we had something called as Oracle Rack. That is where the term rack came into the picture. So in such events also, rack in 9.9 had to rely on another third party uh, cluster management software in order to make those storages visible to the machines connected to the rack system, right? Connected to the system. So what happened was, when Oracle needed to be installed, Oracle cluster needed to be installed, first we had to uh, set up something called as clusterware. So Oracle had to rely on a third party in order to make the machines available so that they could see each other appropriately, and also the storage, right? So storage had was enabled in order to perform concurrent read-write access through multiple machines. So then Oracle thought, fine, now instead of relying on another third party, why can't we come up with our own solution? So that was one of the main intentions of the introduction of ASM. From 10G onwards, they introduced their own automatic storage management solution, or ASM, right? So ASM actually supports both single instance as well as, just a second, let me just take the point out. Alright. So they introduced ASM in 10G, and it was basically supporting both single instance as well as cluster databases. Right. So this is a single solution in order to meet both those requirements. Now, uh, other thing was, it was very scalable. Now, scalable is basically where you have the freedom of expanding the storage on demand, right? So for ASM, it's just a matter of introducing a new disk to the storage, and ASM will configure that as a part of the storage pool. Right now, as an example, if you have a 100 GB disk getting attached to ASM, then ASM will take that into one of its disk groups. So we will talk about disk groups later, but it could take it to one of the disk groups, and then the disk group will grow by 100 GB based on the configuration that you have. Okay, so something like that. So then it was very scalable. It is very scalable, right? And then we have high performance. Now, why I say it is, why I'm saying it is highly performed, is simply because now I told you the conventional setup where you have to use your operating system, and then have a operating system cache layer introduced, where you have to do a file system convert, right? You have to format it, right? But here in ASM, there is no file system cache in between. So we don't depend on ext4 or NTFS. So nothing like that. There's no file system at all there. Okay. So what happens is that, therefore it bypasses the requirement of having a middle layer, right? Which is the file system cache. So directly when when I say client, storage is used by the databases. So therefore, my database would be a client to the storage, right? To ASM in that case. So therefore, when IOPS are performed, databases or clients could directly attach the raw disk and retrieve and store data on demand. So that is where the performance comes into play. And then also availability. So we'll talk about availability. Availability means if there is a corruption, if there is an unavailability of one of your disks given to ASM, how do you tolerate that? Right. So we have features that are there in order to tolerate availability as well. So we'll discuss more about it later on. Okay. And then thereafter, Oracle also introduced something called as ACFS. Now, ACFS in modern world is called Advanced Cluster File System, but previously it was called as ASM Cluster File System, or it's the same abbreviation. I mean, abbreviation in short, we call it ACFS, but now we call it Advanced Cluster File System instead of ASM Cluster File System. Right now, ASM Cluster File System. How can we do that? How can we enable that? Is simply using something called as ADVM, which is the ASM's Dynamic Volume Manager. Right. So I'll brief you on that as well. In case if you are interested, we can talk about it in detail as well later on. But anyway, ADVM allows. Uh, Now you know about volumes, right? Now we have let's say we have a disk attached to a disk group. I told you I will explain you about disk groups later. But let's say for now in ASM we have a disk group having 100 GB of disk space, right? I would use my ADVM in order to create a volume, right? So I create a volume of let's say 10 GB, right? And then format that using advanced cluster file system. So the moment you format it, you would be able to mount that as a file system because it's a file system, right? So you can mount it. Now, the beautiness of this is if you take the raw ASM as is, right, the storage is not visible to outside world. Of course, the database clients can access the disk or the disk groups directly and retrieve and store data. That is possible. But for outside world, let's say a third party or maybe somebody else who's using the operating system wants to store some files, then ASM as is was not possible, right? But with the introduction of ACFS, you could simply use the ASM storage in order to create a dynamic volume. And that dynamic volume could be mounted as ACFS file system, I mean ACFS, and then that could be just mounted onto your operating system, and then just like using a general purpose file system, you'll be able to store and retrieve data from that. But under the covers, the data actually goes and stored inside ASM. So the introduction of ACFS introduced some other additional features as well, such as snapshotting, right? So if you want to have a point in time copy of whatever the file that you have in this ACFS, it could be done with very few, I mean, a single command actually through ACFS capabilities, right? So those are some of the additions that you may see when ACFS is being used, right? So behind the scene or under the covers, you rely on ASM. From ASM using ADVM, you generate a volume, and that volume could be formatted using ACFS and present that as normal mount point to other users to use. And then you can also derive benefits from ACFS while keeping the advantages of ASM because it is the underlying storage anyways. Okay, right. Now, another important thing to understand is that ASM, right, doesn't perform, or we call it the ASM instance, doesn't perform IO operations for RDBMS. Okay, so what I want to tell here is this, right? Now, when you are spinning up your database, right, maybe you would have already learned about this. You have your database instance and the database, right? Similarly, for ASM as well, you have your ASM instance running, right? ASM instance running, and then of course the ASM storage will be there underneath. So the whole purpose of the ASM instance is to mount the disk groups that we have created using ASM, right? But then you have your database. So when the database wants to retrieve data, database will not talk to the ASM instance in order to fetch data on behalf of the database. But the database can directly access the ASM storage and access data if they want, right? So what is then the purpose of ASM instance? So ASM instance is basically there in order to provide metadata for the database. Now, metadata means what? So it's in simple terms, data about data, right? So the ASM instance. Now you might see ASM instance type. No, it goes as instance type ASM. Normally for a database, the database as a parameter instance type will go as RDBMS, right? So this ASM instance will basically, now you can see this diagram also here, right? Just a second. Oops. One second, I lost my screen. Let me share again. Okay, something went wrong there. Okay, fine. So you have your ISM instance. I told you about the disk groups. We'll come to that later again, right? So what I want to highlight here was, so when you have your disk groups, okay, when you have your disk groups, and when the database wants to access data, database can directly access the disk group, but ASM will give information or metadata such as what to be accessed. Now, when database wants to access a certain set of data, the database should know where the data is directly stored, right? Exactly stored. So information about such data will be cached inside the database instance, right? ASM will give all the metadata required for the appropriate database to directly access the disk, right? Or disk group rather than going through another ASM instance. So that will be more slow as well, but it is not going to happen anyways. The database will have access directly to the disk groups, right? So as I was telling before, ASM instance is just another instance, just like your database instance, but it will have very few amount of parameters. So I've listed here the number of parameters that will be used within the ASM instance as well. The good thing is that generally we don't need to tune these parameters, right? So performance tuning is an important topic in our database management aspect. But then for ASM, we don't need to tune that much unless there is a specific requirement of doing so, right? But the default provided values are quite sufficient in order to run the ASM instance, right? So then. What sort of information? So I told you again, for ASM instance, the idea here is to to mount the disk groups, right? Now I will just brief you on disk groups because the term disk groups is coming quite often here. So when it comes to storage, let's say we want to have, let's say we have 100 GB disks available, we have 10 100 GB disks available. So what I can do is I can combine them. Let's say I will combine five of them and then create a group. So this group will have five disks of 100 GB, and those performance will be kind of equal, right? So if you take the RPMs, if you take, generally those will be equal because that is how we should be presenting the disk groups. Because otherwise, the ASM instance might not know the difference, performance levels of the of individual disks, right? So anyway, so you provide these disks to this, and then you can create a group. So 5 disks, 100 GB into 5 is 500 GB, and you create a disk group, right? You can name that group, and that is the group that the clients or the databases will be accessing. So you can have multiple disk groups created within one under one ASM instance. So the whole purpose of the instance, when you start up, just like how you start up a database, the ASM instance will go and mount the disk groups. So that is the only task which ASM will do. ASM instance will do when you do a startup. Okay. So I also told you about ASM providing needed information to the database to directly access the disk or disk groups, right? So here you can see on the right hand side the required metadata that will be made available through an ASM instance to a database instance so that the database instance can directly come and access the disk groups. So I hope this part is clear to you. If there's any question, please feel free to raise your hand, or then and there you can stop us as well, or you can just post your question on the question or chat as well. So whatever the way, and I think we told you earlier as well, there is no barrier in terms of the language, so you can ask anything in any language that you like. Of course, language that we can understand, right? Okay. So let me just go through the to the next section as well. Okay, so here we come to the section of ASM disk group. Now I think you have an idea about a disk group. So how do we form a disk group, right? So here I just have taken a screenshot from 19C, right? Then first you have to identify the disk, right? So you have to set your permissions properly, and then from your graphical interface, you'd be able to see the disk, right? So are we creating partitions from the disk? Ideally, no, right? So you have to give the raw disk as is, right? Is it not possible to break the disk into small partitions and provide them as separate disks to ASM? It's possible, it will work. But the problem is that ASM will not know that the partitions that you have given are from the same disk. So if there's a failure, it will impact all the partitions and the whole disk will go, right? So it might not make sense. So therefore, it is important to provide separate disks, right? But when you're talking about separate disks, of course, from the storage perspective, storage vendors will give you not disks. They may give you LUNs, or we call it logical unit numbers, or a virtually created disks based on many number of disks. Okay. So that could be the situation here. So if that is the case, then we don't need to worry too much about it, because the storage management is taken care of by the storage provider, right? The hardware provider who has created LUNs, who had basically created LUNs. So in that case, obtaining a LUN is not going to be a problem at all, right? But what I'm saying is that if it is a directly attached disk or set of disks, don't break them into partitions, because ASM will not know about the real partitioning. Okay, they may, or ASM might think that it is a separate disk altogether. Okay, but then again, in modern world, we don't probably get disk as is, but the storage vendor, hardware provider, will give you the disk as in the form of LUNs, right? So logical units will be given to you. Then those logical unit, if you take a single logical unit, it might comprise many partitions from many disks. So that is not a problem at all for us, because it is basically a part of the storage provider who would be managing the fault tolerance there. Okay. So then what you do, you select that disk, and then you can start creating your first disk group, right? So likewise, you can create many number of disk groups. There is no limit to that. But then there are a few things that you would be coming across when you are creating your disk group, right? Of course, I told you that the disks will be raw disks that you'll be given, because you're not going to format it and give, right? You don't put ext4 on Linux system and then give that to ASM. That will not work. So it has to be given in the raw format, right? So that is how Oracle will recognize it, or ASM will recognize it. And then there is something called as an allocation unit, or AUs, right? Now AU, maybe you would have heard, if you take the smallest IO element in a database, it's a database block. So you can determine the block size, and that is the smallest IO element that you have in the database. Similarly, for ASM as well, there's a smallest element that will deal with IOs, and that is going to be an allocation unit. Okay, so what is the size of the allocation unit you want to have? You can figure it out. I mean, you can size it. So here the smallest is 1 MB, but in this picture you may see that the allocation unit has been selected as 4 MB. So it can actually vary from 1 MB to 8 MB. I think if I'm not mistaken, I can't exactly remember, but you can drop down this and then pick the number that you want, right? Now, if your disk groups, this is creation of disk group. So when you are creating a disk group, and this disk group will be mostly used by a database that is more towards warehousing, then you might be doing lots of sequential reads. Batch reads will be that batch reads will be done. So in such cases, giving a larger size for your allocation unit is more favorable. Okay. So, but then again, if you go with appliances like if you have heard of Oracle Exadata and so on, there are predefined allocation unit size that you may find in those appliances as well. So those have been optimized for such, right? So in general terms, you can start with one, and you can for that you can decide what's the exact size that you want to have. Okay, right. Now, then comes something called as extents. Now, this is a very important section. Now, extent means, now, let's say you have you know in your database, what you store is files, right? Let's say a data file that you are going to store. So the data file will be broken into small chunks, right? Now, let's assume I told you an earlier example in a disk group where I have 100 GB 5 disks, right? 5 into 100. So what happens is, if when I'm creating a file in the database, that database file can be broken into maybe five small chunks. I mean, I'm not saying exactly five, it could be more, but I'm just taking an example here. So you have five chunks. So the data file is not residing on a single disk, but that will be spreaded across those five disks that you have in that disk group. Obviously, it is going to be more than five, but I just took that as an example, right? For you to understand. So when you break a physical file into small chunks and spread it across the available disks in that disk group, this is what you call striping, right? So you stripe your data using extents. So what is the size of an extent? Because you need to know the size of an extent, right? Initially, the size of an extent will be equal to the size of an allocation unit. All right, makes sense, right? So first, ASM extent will be equal to uh, allocation unit size. So if your allocation unit size is 1 MB, now in this case, allocation unit size is 4 MB. So your starting size of ASM extent would be 4 MB. So if you have a let's say a 40 GB, or sorry, 40 MB file, I'm just saying, then with 4 MB chunk size, you'd be able to have 10 extents. So those 10 extents will be spreaded across the number of disks that you have in a given disk group. Now here I'm giving a disk group name as EBS data, right? So in EBS data disk group, if you have here, of course, you only one disk is presented, right? So therefore you cannot spread like that. But the moment you have multiple, what you call multiple disks getting attached, now later also you can attach, right, to the disk group, and then that will be spreaded accordingly, right? Now, if your file size is getting bigger and bigger, just 1 MB of extent sizes or 4 MB of extent sizes might not really help, because you may have quite a number of, a significant number of extents, right? So in order to cater to that, the moment the file is growing bigger and bigger, right, it uses a certain algorithm in order to size the extents by multiplying the number of allocation units. As an example, once it reaches a certain limit, I'm just saying an example. Okay, let's say once the number of extents reaches say 20,000, maybe your allocation, so your next extent size will be multiplied by 4, right? So 4 times the number of current allocation unit size. So then it will be bigger. right? So the figures that I told you may not be accurate. I just took as an example. So that is how it grows, right? More the file size, or when the file is getting bigger and bigger, the extent size will also dynamically grow. Okay, so that is why it is varying, right? Anyways, so once once these extents are created and your extents are allocated across the disks, you need to have an extent map in order to figure out where the pieces are, right? And that is the map, right, that will be shared within your shared pool of the Oracle database. Okay, I told you that ASM will share metadata, right, to the database so that the database can directly access the disks, right? So once these extend maps are shared within the database instance, the database can directly perform IO operations against a disk group rather than going through a ASM instance. All right, hope that makes sense. And then we come into redundancy. Now the redundancy levels, okay, we'll take the first one, which is external. So when you take external redundancy, in external redundancy, you don't provide any redundancy because it is external. Now, I told you a situation in modern days where storage vendor provides you logical unit numbers or LUNs with redundancy enabled from the backend, right? So if a disk fails, so the storage or hardware vendor knows or the storage provider knows how the tolerance has to happen. So
Can
therefore, we don't need.
can small
Hello.
interruption because
Yeah.
we are this meeting will be closed within another 2 minutes. Guys, you can join. I
Okay.
ඔයගොල්ලන්ට join වෙන්න පුළුවන් මේ ඔය link එකෙන්ම මේ meeting එක තව විනාඩි 2කින් ඔයගොල්ලන්ට break වෙනවා. නැත්නම් අපිට break කරලා උනත් ගන්න පුළුවන් ගෑන්.
Okay. So should we break now and connect or?
Whatever convenient.
Okay.
Yeah, go ahead and
Um,
we will. I think within 1 minute, can we finish this slide? Or
I don't think so. I don't think so.
okay, shall we close it and reconnect again?
Yeah, yeah. So we'll connect back.
Okay, okay. We will end the session
All
and
right.
we
Let's.
will join again. Okay, bye.
Sure.
Not
Sure.
bye
Thank
actually.
you. Bye.
We'll join again.